Welcome to this session. This is the 12th from the track 3, Galleries, Libraries, Archives and Museums. Well, the first presentation is from Zhaoyu, from Xi'an, Jiaotong-Liverpool University from China. And the work is development of 3D modeling gallery based on virtual reality. So can you start?
Okay, thank you, Dr. Pedrosa. And I will share my screen. My name is Zhaoyu, and I'm from Xi'an Jiaotong-Liverpool University from China. And I'd like to introduce our research work on the development of the 3D modeling gallery based on the virtual reality. The 3D modeling is a fundamental process for the industrial manufacturing and is an essential skill for the designers and engineers engaging in the design activities. The traditional course of the 3D modeling is usually delivered through the briefing lectures and computer practices. The lecture delivered knowledge mainly by the projector slideshows or the real-time demonstration. However, this teaching approach does not fundamentally change the limitation of traditional teaching or maximize the students' initiative to learn the 3D modeling. VR technology can generate a simulated environment in which users can immerse themselves and interact. With the rapid advance of VR technology, it has grown beyond its early limited applications and has been applied to various areas of relevance. In recent years, the combination of VR technology with education has also gained recognition and popularity. VR shows promises to benefit the 3D modeling courses with irresistible advantages. For example, learning modeling in VR breaks the limitation of time and space and allowing students to enter virtual scenes to experience the 3D modeling. The students' learning process can also be accelerated by feeling the scale and the depth of the 3D models and experiencing the modeling concepts and methods in an immersive learning environment. Immersive technology, such as virtual and augmented reality, is currently a very promising tool and is increasingly used in a variety of fields. Most industrial design students still learn 3D modeling using the traditional learning method, which means lectures demonstrating the modeling process and modeling operations through the slides. The conventional lecture-style settings arrangement used in the 3D modeling education can result in the inflexible learning, as the singular and unchanging teaching method can limit children's ability to experience and develop their own ideas. For 3D modeling education, VR breaks the two-dimensional space of the traditional computer screen and brings students to a new dimension of experience and interaction and a higher level of engagement. The aim of this project is to develop a 3D modeling gallery based on the virtual reality that can gamify the modeling lessons through a virtual campus scene to inspire students' interests in modeling and allow users to manipulate the model in the 3D modeling gallery and understand the construction of the 3D model and gain the modeling instructions. The first main feature of the 3D modeling gallery is a virtual campus scene that allows students to explore the 3D modeling through the virtual models of their campus building, shown in the two figures. In order to provide students with an immersive learning experience and improve students' motivation for learning 3D modeling, the virtual campus scene in the gallery was built with reference to the author's campus. By scaling the real scenes to an appropriate scale as virtual scenes and reconstructing each of the building models, the students can feel the novelty of the 3D modeling and can be inspired to learn this skill. The proposed system provides two movement options in the virtual campus, including the joystick and teleportation. Students can walk freely around the scenes in the virtual environment and navigate the vibrant virtual campus. When touring the virtual campus, students can switch between the joystick movement, which is more precise but slower, and teleportation, which has larger step and is suitable for the longer distance. The practice showcase of the 3D modeling gallery is located at the gate of the Western, one landmark in the center of the South Campus of the author's university. Students can interact with the 3D model by using the VR controllers, which will appear as the virtual hands in the scene. When the virtual hand meets the 3D model, the controller will provide a vibration feedback to indicate that it is ready for grabbing. After grabbing the model, the users can freely manipulate it by rotating it in any perspective or moving it either closer or further to observe all the modeling details as presented in the first figure. As the user controls, the models will change sequentially to demonstrate the different stages in the modeling process. When the users aim the right-hand controller at the model, a ray will appear in front of the right-hand controller, indicating that the modeling process demonstration is ready to start. The user can then trigger the model to switch to its initial modeling state by pulling the trigger on the right-hand controller. Subsequently, each time the user aims at the model and pulls the trigger, the model will switch in the order of the modeling process until it reaches its final state. The second figure shows the state ready for the demonstrate the modeling process. And if the users get confused about any of the modeling stages, they can use the virtual hand to press the tips button in the scene. When the button is pressed, the operation performed at the step appeared on the model, and the part that changed due to the operations is highlighted in yellow color on the 3D model, providing the user with a virtual and accurate tips shown as the third figure. When the virtual hand leaves the tips button, the button will automatically pop up and the modeling tips will be hidden at the same time. The soundback will be provided when the button is pressed or popped up to inform users whether the operation is successful or not, in order to enhance the interaction experience of the users when displaying or hiding the modeling tips. A user test was conducted through the experiment to investigate the effectiveness of using the 3D modeling gallery system as a tool to enhance students' learning of 3D modeling. 12 participants between the ages of 18 and 30 were recruited for the study. All participants have no prior experience in the 3D modeling and had not received any prior instruction in this subject. In the first phase, participants learn how to model using the traditional instruction method and finishing the survey. In the second phase, participants use the 3D modeling gallery to study modeling and finish the survey. As shown in the figure, the experiment results show that in three aspects: the ease of the understanding the model, confidence in completing the modeling exercise, and interest in modeling. The combination of 3D modeling gallery and the traditional learning demonstrate significant advantages over the traditional learning method alone. Moreover, in terms of the efficiency of the learning process, the result indicates the significant advantages of combining the 3D modeling gallery with the traditional learning. The results have demonstrated the benefits of using the VR technology for education. The immersive nature of VR can enhance the learning experience by providing a more engaging and interactive environment. The use of VR in this study allows the participants to interact with the model in a more natural way. which could have contributed to the observed improvements in learning outcomes. One limitation of the current study is the small sample size, which may limit the generalizability of the findings. Future studies with a larger sample size could provide more robust evidence of the benefits of using the VR technology for modeling education. Overall, the results of this study suggest that the use of 3D modeling gallery in VR environment has the potential to enhance the effectiveness and the efficiency of learning the 3D modeling in design and engineering education. This technology could be particularly valuable for students without any prior modeling experience, as it provides an immersive and engaging learning environment that can facilitate the acquisition of new skills. In conclusion, this study developed a VR system for educational purpose to assist the learning of 3D modeling for designing and engineering students. The whole system is based on a virtual campus, which allows users to move freely through the scenes of the campus, wearing a VR headset and touring the campus. The practice showcase in the system is designed for the students to freely select a model from the module practices they want to view and manipulate, better understand and construct of the model, and obtain the modeling guidance. For future work, another feature to be added into the gallery is a virtual photography studio for the lighting in the rendering of the 3D model, which allows students to freely move the position of the lights and set different light intensities in the VR environment to learn about light in the rendering. Okay, that's all for my presentation. If you have some questions, I will be happy to answer them.
Thank you so much for your presentation. It's really, really interesting work. Somewhere have questions. I see in doc we have 2 questions, but the participant can put the questions for you, for you. Sorry,
yeah.
My pronunciation, your name. I think it's Tariano, right?
Okay.
Yep. All right. Hello. Yeah. So I've written 2 questions. So first of all, about the 3D gallery that you used, which is a very interesting concept. The shots of the presentation was very clear. So was it a single user or a social environment? And in case, if I understood, it was a multi-user experience. I was wondering to know, I'm curious, whether this, what kind of platform or system was used, and whether you encountered any interesting peer-to-peer or informal learning experience. That's the first question.
I think this system is run in the it's for the single user, yeah, and it may be used in the modeling class, and the lecturer can bring the VR headset to the classroom, and students can use this VR headset and the controller to use the system, yeah.
Okay, that makes sense. So the second question was, what was the numerical scale that was applied in user evaluation questions? Because I see the chart that was from -2 until 2. So I was wondering what scale did you use? What were the values that participants could choose to evaluate the system and the questions that you asked in the survey?
Sorry, can you repeat your question slowly? Yeah.
Okay, surely.
Yeah.
Well, the question was about the graph that you showed with the results from the user evaluation. So there, I've seen the chart, the bar charts that you used in the different questions, that there were, some of them are high, some were low. So I'm asking, what was the scale? What was the numerical scale that you used, the numbers that they could choose to say, oh, I'm satisfied, but what was the maximum and the minimum of?
Okay. I will show that slides and do some explanation. Sorry. Yeah, it's in
right, that one.
Yeah, and the first question is about ease of understanding, and the question is I will understand the modeling very easy, and the scale is -2 is strongly disagree, and the 2 is strongly agree. Yeah.
Okay, that's clear. That's what I wanted to. That's what I want to clarify. Thank you very much.
Okay, thank you.
Thank you so much, Stelianos, and you for the questions and for the discussion. Somewhere, anybody have some questions for you? No, I have one question. You say that the students immerse in this 3D gallery, right? Well, what is the feeling of these students when in this gallery? What you see when the students interact with the objects, with these elements? What is the contribution for their learning?
The feedback from the participants is they think the 3D modeling gallery is very different from the traditional courses, and it's very interesting, and it can maybe inspire them to study hot modeling, and you know, the virtual campus is reference to our university, so they will feel very amazing. Yeah, they think the virtual campus is very interesting. Yeah.
Okay, thank you so much. Well, we move to the next presentation. The next presentation, thank you. The next presentation is presented by Stelianos from Greece, the University of Patras, with work STEAM project exhibition in the Metaverse for high school students affective empowerment. Can you start, Stelianos?
Thank you. Thank you very much.
Okay.
Yeah.
Remind you 15 minutes and 5 minutes for discussion, okay? Thank you.
Right. Yes, so I will be quite brief. So no worries. Hopefully you can see my screen clearly and you can hear me. So this is the title of our work. And I should mention that our co-authors, Ms. Theologikouti and Professor Iliopoulos are also in the audience to address any questions. So we explored what will happen if we use a digital exhibition in the metaverse for deaf high school students to exhibit their project work. So let's see. So what motivated us to engage with this work? First of all, we were aware that students with hearing impairments, they face several challenges in school education. They have fewer opportunities to develop their skills. And then after school, they have problems to find employment. Now, we know that deaf students and students with hearing impairments, they can be helped by collaborative transdisciplinary projects. However, there are very few of them, so more students of this nature are needed. So we wanted to explore okay, if they engage in such a project and they have the opportunity to exhibit this work in the metaverse, what will happen? So this is the curiosity behind this work. Now, a few words about the concepts behind this work. Now, first of all, STEAM is STEM plus art. So science, technology, engineering, mathematics with art. And that's something that gives the opportunity to students to enhance their creativity and innovation when they combine logical, scientific work and also technological skills with artistic expression. Secondly, the metaverse and multi-user social virtual reality environments, we know they can be very advantageous for people and with disabilities, and have been very interesting studies also presented and published in the also in this conference in previous years. Now, concerning now museums and digital exhibitions, we know that they have been a popular medium and have been used frequently, and also in virtual reality. However, most of the cases, these are single user experiences. So there's a lack of social interaction, hence the innovative aspect of our solution and our proposal. So first of all, but who are we? Okay, yes, you might know Greece. So Patras is here in the western part of Greece, where we have the University of Patras and a wonderful, very active museum of science and technology. And here you see some snapshots of our buildings and of cases. We have here scientific experiments. We have also permanent exhibition about telecommunications, unique in the world. Telephone center that has been reused and is available there, and it's in use. And also we have our auditorium where we hold our events. So so as I said, our museum is very, very active, and we have thousands of students that are visiting us every year. So one of the activities that we organize are some projects that are called thematical network projects. So these are projects that last for 9 months. So they start from September and end in June or May. And here you can see the posters of some previews of such projects, thematical projects. That the first one is about ceramics, the other one is about the Antikythera mechanism, one of the first analog computer in history. So here's how it works for you to understand. First of all, we come up with an idea mostly and most of the times already from the previous year around a topic that will be of interest to schools and school students. And then starting from the academic year, we organize and host a series of webinars for the teachers from interested schools to participate and be educated and be aware of all these topics. Then during the year, the schools with educators, they come to our museum and they engage in a series of experiential informal learning activities, playful one. Most of the times. So the students, they learn, they experience, and they engage with the subject. And then it's their time to shine and be active. So they form their groups in the schools and they start working on the project because they have to deliver and actually prepare something. And then comes the final event at the end of the year where all the students present their deliverables. But that's not all. This work then is then exhibited in the following year for other schools to come and visit and explore. And moreover, we finally develop new educational services and experiences for new schools to use and learn. Here are some snapshots of how this actually looks like. So here is a snapshot from a webinar with educators. Then you see here a visit from a school with the students. You see here a live experiment. Here, then comes the final event with the presentation. You see it's quite crowded. So these projects are very, very popular because they deliver something which is missing in the traditional school education, which is exploratory project work, transdisciplinary, and also experiential. And then you'll see our room for temporary exhibitions. All of this that you see around this room is work from students. And here is something, how this or material can be repurposed into something new. Here, for example, you can see a board game that was created thanks to the students' work in such environments. Right. So now we come to the academic year 2020-2021, and the topic of one of these thematical network projects was digital literacy, inspiring and education the citizen of the future through the museum. And on the left, you can see the poster, and to the right, you can see the names of the 7 schools that participated in this particular project and work on it. Now, in terms of use of immersive technology, what we did was quite simple and not very fancy. We organized a virtual exhibition in the Metaverse to demonstrate what the children had created. And this was a social multi-user platform where avatars could interact and communicate in an open environment, just like they would in a physical museum. Now, remember, we are in 2021, so the pandemic is raging, and or physical activities and visits to museums and other places, crowded places, are not allowed. So this is the solution that we found. So concerning the research, we wanted to explore the effects of exhibiting this work of the deaf students in the Metaverse, and we used a case study with the participants were 7 students with hearing impairments and 2 of their teachers. For data collection, we used student observation and also semi-structured interviews. And here's how our interview protocol looked like, what they asked them about their visit of the VR exhibition. Now, so far, so let's take a closer look of what these deaf students created. Well, since it was 2021, it was 200 years since the revolution, the Greek revolution that led to the creation of the modern Greek state, the modern state of Greece. So they chose to create this this parallel and of the heroes that fought for the revolution, and also the modern heroes, which are the doctors and the medical personnel that also fought and for all of us during the pandemic. And here's what they created. Here you can see some of the digital creations, presentations. You can see videos with recordings and interviews with scientists, and also quizzes and so on. They did an elaborated work that was exhibited in the Metaverse in our digital exhibition in virtual reality. So let's take a look of what happened. And those results revealed that there were some social ripple effects that were not anticipated on the students themselves, but also on the school peers that are with and without hearing impairments, but also with educators in the wider school community. More specific, 3 themes emerged. First of all, the students themselves, they had enhanced self-confidence and sense of pride. More specifically, the first emotion that they had was they were surprised. They had not experienced such kind of environments before, and so their perception of this virtual exhibition, they saw the space as official, as real. It was not just a web page that was something that someone could visit. So they felt very proud, and they saw that their work was featured in a legitimate, a real museum space, and so they realized that their work was recognized as equal and worthy to be exhibited along with the work of non-deaf students, and that enhanced their self-confidence and self-efficacy, that they can actually be successful and achieve their goals. And so that was something new for them. And this triggered the second second series of events, which was that they were this pride about their work led them to demonstrate their work to younger deaf students, and these younger students, they were also in turn inspired, but they revolted and say, how come they participate and they do such interesting things that we don't? So they asked to participate also in similar projects from their teachers. So they wanted this freedom to express their creativity and use tools and technology to prove their abilities. And so that led to also a peer recognition and wider discussion in the school community. First of all, the teachers also shared what was happened and also on the website. And this led to an enthusiasm from other computer science school teachers. And they were also inspired to design new projects, collaborative projects within classes of hearing and deaf students to work together on similar projects. Plus, the students themselves that produced this work, they shared the Metaverse exhibition itself with other students with hearing impairments nationwide, so all over the country. And that sparked new discussions among these audiences of deaf students on these accomplishments and how they could also use them as well. So, of course, this study had the limitation of a small sample, and to the fact that some of the beneficial effects could be attributed to the nature of the project, which was very creative and practical, that involved authentic tasks. However, we think that are a series of implications for practice and for museums that they can use. First of all, they can use the Metaverse to engage new and younger and remote audiences. And the fact that museums can be, especially science museums, can have a role in education. They can coordinate interdisciplinary, experiential, collaborative learning experiences, and they can be the epicenter of a co-creative model where schools and museum and students, they all collaborate, they all are participating in a community, and they constantly produce services and experiences that are meaningful to their students for the development. And finally, on a policy perspective, the Metaverse can be an equalizing factor because it can provide access to services to remote and rural schools and populations that normally would not have easy access to come physically to a museum. And with that, I would like to thank you very much for your interest. Here are here's a goodbye from our friends of the students and the students with hearing impairments that created this wonderful work. So we are thank you very much for your attention, and we're looking forward to your questions.
Thank you so much, Stelianos. Is the project really interesting, and also with some challenges because your population is special, right? So, any questions for Stelianos from the participants in this room? Well, Stelianos, I have some questions, and I'm curious, of course. In terms of the research instruments, what do you use for verify the self-efficacy, self-confidence? What you use for your research?
Right. Well, this research was qualitative. You show that this sample was quite small, so there was not a lot of students. So instead of using such a survey and questions, we thought a qualitative method was best to achieve in-depth knowledge and understanding of what they felt and what they understood. So we asked them directly, and we also observed them during their visit when they came here and they came to our museum.
Okay, you have this observation, you use some previous guide. What is the questions that you use? Is the experience, learning? What is the dimensions that you analyze?
Right. Well, yes, I should also mention that we had also the interviews. So we asked them, first of all, as I said, our primary research goal was to understand if the Metaverse exhibition made any change to their perception, how they felt. And so we asked them all details about if they visited the digital exhibition, what they did, what they used, and what they felt, and if that made any difference with previous work or previous methods that they had used to maybe show their work, if at all, and so on. And apparently what made a lot of a difference was the fact that this exhibition environment was all completely open. So it was not confined with something which was in a class only. So the fact that they could invite other people in, they could see, the fact that they could see as equal in terms of the space, that here's our work, that I am deaf, and here's a work of another one who appears deaf, can hear, but they see equal, or even ours can be even better than that. So this helped to boost their confidence and see that what they do is on par with their other school peers. So all these are all the dimensions that we used, and this was also, we triangulated this the self-reported data with their teachers as well, because we asked them after also what happened afterwards. After the exhibition was over, after the project was over, and they told us of a story of some of the students who felt inspired and they empowered through this event that was marked through the exhibition in the Metaverse, to so that they saw that have a talent, for example, for technical skills, and they decided after school to follow such a profession. So this empowerment led to decisions regarding careers. So I hope this provides a little bit more insight.
Yes, yes, thank you. Another question is, this population is very special, right? It's the deaf students. Well, how they use this technology? What is the direction between the students and between the museum? What are you feeling about their learning with these moments, with these projects? You feel that improve their learning, their contact with other colleagues? What is the skill that you can see that they development?
Yeah, obviously the fact that these environments are multi-user, that they allow for informal learning to appear, so they have interactions, they can come together with their own peers, but so they can self-organize. And definitely with the museum, as we are at the very heart, we have a co-creation approach and strategy. So we're not saying, oh, we are the wise, we know how we do it, we'll do organize there, and you'll come here, and since we're the wise people, we'll show you how to learn. No, instead we have equalizing strategy, and we invite educators and students as well to come as well and participate in this whole space and the projects that we organize, and we give them the initiative. We hold regular competitions in the local, regional and national level, which are very popular. For example, this year we held a competition around digital escape rooms, for example. So in the future, we see that the students themselves, they should be the creators of such environments in the space, and they can contribute actively, and they can have agency, and they make them all these spaces on their own. So this is the direction: active learning through the empowerment of the learner, through co-creation with the educators, the school community, to address the needs of all populations as much as we can towards literacies that will be useful in the 21st century.
Thank you so much, Steliano. It's very, very interesting, your projects. I will accompany your projects. It's very, very interesting. So any questions from other participants? If not, I move to the final presentation with Xi'an Yu from China. The institution is Xi'an Jiaotong-Liverpool University, with work design and art basic materials library for higher education, offering a for now learning structure for design and engineering students. Thank you. Can you start?
Hi. Hi everyone, I'm Yuan from Xi'an Jiaotong-Liverpool University, and I'm happy to tell you about our project about designing an AR-based material library for higher education, offering a full-node learning structure for design and engineering students. So, material education is essential for design and engineering students. Many universities have already tried to set up a material library, while a more futuristic and sustainability way is still innate. Indeed, the development of immersive technology offers broader possibilities for education, and particularly, AR complements the physical environment or objects in the real world with computer-generated visuals. So, by incorporating sensory experience provided by physical material library with the informative benefits of AR technology, we tend to offer an AR-based material library with full-node framework for material education. So our related work contains two main parts. First is about material learning, how a product is manufactured, how it functions, and experience are affected by its designer's choice on material. And some universities allow direct access to material samples in physical library, while some have ventured into the development of online platforms. In addition, new materials are continually evolving, so the demands for information are growing. And so we need to advance knowledge of material to create an ideal user experience for product. Another aspect is related to AR-assisted education as an emerging technology in the information age, allowing for deeper sensory experience by overlaying virtual information with physical reality. It can boost students' engagement, interest, and motivation. By laying knowledge over physical environment in a digital way, it delivers novel experience, which could be a guidance for material education. Here demonstrates our system design based on the full-node structures from on the top to the bottom. From node 1, it provides the introduction of material, contains some brief and sensory properties. And second layer is know who. It's related to application, like the industries and cases. And the third one is know how. It provides design guides, contains material, pros and cons, and also sustainability. The last layer is know why. It provides a technical reference, like some information can be measured. And here is our information architecture of system. We have two main functions. First is information retrieval, and second is AR showcase. We collect material information from publication or open source and sort them into according to the full-node framework. And we also provide some information for the new materials. And for AR showcase, it's mainly used in case study, and I will demonstrate later. So we developed the application by using Unity along with C, and we use a referral engine to support some AR features, enabling application to recognize images and configure them for real-time interaction. Here is user interface of our final design, from homepage to material library page and material content. Particularly as a new material, we're in homepage and it provides some short information. And for AR showcase, it can be retrieved by scanning or from the page of case study. So here is a video for the application. If you click the scan, and then you can recognize some QR code about the material. And then if you go to the material page and look through, click the case study, then you can view this material like green caster area in the keyboard. You can view the texture and the effect. And also, we also have other materials for the chair. Yeah, so later we run the user test. We found 14 students from design and engineering majors. And first we like them to view the demonstration of features from homepage to material content page and AR showcase. And then they fill in questionnaire consisting of usability and kind of models. So usability is a like scale, consists of 10 items that helps to assess usability in a statistic format, while Cannon model is an analytic tool to assist in understanding about users' emotional response to a product or function. So the overall usability score is at a good level. And the Cannon model indicates the role of different function on the right imagery. For AR showcase and new materials, they are attractive for the users, and where for material search is like the content of material, it's indifferent for users. And for material content, it's a must be for them. So in conclusion, usability is positive for current system, and participants shows their interest towards AR showcase used in the material case study and also new material parts. We deliver a differentiated experience that allow users to explore the material learning journey actively. For future week, we will mainly focus on 3 parts. First is about material data collection and collocation. We tend to collaborate with more organizations to supplement new materials. And we will also refine the implementation of AR. Like we tend to allow students to render their own model in a real time by selecting suitable material from the library. And we will also to improve the system evaluation. As fuller functionality is developed, control trail based on different learning methods will be set up for further user research. Our contribution have a couple of aspects. First is about multidisciplinary integration, as knowledge is fused together to trigger dialogue between multiple parties. And AR technology is applied to broad students' sensory experience and supplement perceptual information in physical material library. We introduce a section on new material that promotes information updates and offer new insights to students. We also promote sustainable development of material education. So in conclusion, we propose an AR-based material library to facilitate material education for design and engineering students. We explore practical application of AR in education, and we design the 4-node learning structure for material education. The overall results from user test confirm the importance of AR applications together with positive usability assessment. Yeah, that's all for my presentation. If you have any questions, I'm happy to answer.
Thank you so much, Yuan. It's very interesting, your work. So any questions from audience? Saliano, Zhaoyu, Penny, Leopoldos. Any questions for Yuan? No? I have one question. In terms of students, when they use these materials, in terms of learning, what your findings in terms of learning? Their manipulation, you can see some effects, or you notice your focus in this study.
Yes, because currently I'm mainly focused on the usability and also their positioning of different functions. And so my question here is tend to simple because it's still in the front in the first stage, and because it will develop further, and so now I only focus on the whether it's useful for them and how they view different functions value for them.
Okay, thank you. Salianos, can you ask your question?
Yeah, sure. So what are your plans for the future? Do you intend to continue this work? And if yes, how?
Yes, I plan to further this study. And so currently the system is already determined, and the basis is also designed, but we tend to find more materials and to make the application fuller functionality. They have a different content. We will fill in the actual more contents, more information about materials, and we also will combining with more AR technology, because currently it can be only viewing in case study, like you can see the effects. But in the future, we also want to explain more about AR, like students have their models, and our application can recognize their model, and they can select the material by themselves, because now the model is from the database, and yeah, we tend to make it more engaging and closely with students' actual projects. In this case, they don't need to make it real, but they can from the AR world to see how their product is look like with different material. And it can save a lot of time and money, and to also improve their efficiency in design.
Okay, thank you very much. If I may suggest something, because I love this system, I think it will be very useful. If you can integrate, if you can think of a meaningful activity or interaction to put there, something that they can use not just to read, but also to execute something, some kind of task, some kind of work, or that might also be useful. Although I'm not sure whether it's applicable in your case, if the mission is just to provide information. But if you have a goal, a learning goal, maybe that would be an option.
Yeah. I think this is a good idea, because currently it's mainly on the how to say, it's not actively learning, but if you have some task like a game, gamification for this app, maybe it will be better for students to engage in the learning activity.
Yep, I agree.
Thank you.
Thank you. One more question is about your system design. What are the challenges that you feel when you design this system, and what is your recommendations for the other people that use this design?
You mean that what challenges I encounter for develop this app?
Yes.
I think the most challenging things is about the content, because for every materials we need to find a lot of the information and then coloration them into our learning structure. So it's much more time spent, and it's hard to find all materials that's used in the real world.
Okay, so thank you, and thank you for all authors. I don't know if any more questions from the public. Okay, I think okay. Thank you, Giaotong-Liverpool. Is very interesting, this session with 3 words different, but with same goals for improve this research. So thank you for all for your presentations, for your work. I wish for you and have a nice weekend, have a nice conference, and thank you so much for our presenters.